first and foremost, where we come from is ensuring that it's safe. We don't want to make the problem worse, or by creating a new problem, trying to address certainly a global one. There's multiple ways of looking at that. One, it's really all about site selection. We are not going to operate in areas where there are concerns for certain sensitive aquatic species at risk. Nonetheless, the process itself is so tried and true, so well tested, and because it's a natural rock, we can't actually, even if we tried, overdose. For example, limestone powder is one of these really wonder materials. It plays such an important part in the ecology of fresh water and the ocean, for that matter. We could add 100 times more than what we would to operate in a natural condition. We could add 100 times more in error, and the river will only absorb so much of it. It actually has a natural built-in buffer that it'll push it to a certain point and then simply stop absorbing beyond that. Anything beyond that would be problematic. The beauty of what we do is that the overlap between what ecologically is needed to restore the fundamental process of organisms balancing salts in their body and using calcium to build healthy gills, or using calcium to create their exoskeletons if you're a small sensitive mayfly. Those same targets, as far as the concentration of CO2 or bicarbonate, or more appropriately, the concentration of calcium in rivers, that overlaps really well with the targets of where we need it to be from a CO2 perspective, so that we efficiently pull down carbon dioxide and take it to the ocean for long-term storage. It's not a scenario where we have two at odds targets. They actually overlap almost perfectly, and we simply want to create the conditions where CO2 is drawn down, and that happens to be the conditions where freshwater life can flourish. So calcium is one of these elements that we would consider a base. Calcium is obviously fundamental for humans, fundamental for turtles and fish, and anything that is reliant on water. Calcium is important to bones and all of that sort of structure in our body, but also important for things like how fish interact with oxygen on their gills. When a river or the ocean becomes acidified, too much acid, where you've thrown that acid-base equilibrium out of whack, what happens is calcium and magnesium are two of the elements that are first to go. They're used up by those acids and consumed, trying to offset or balance that extra acid. And so usually in a river, what happens is when we acidify a river, all those super important elements are stripped out, and then what we see is productivity plummets because those key fundamental elements are gone. When we introduce limestone back into a river, again, the dissolution of limestone in water with CO2, what it does, it creates this big bicarbonate molecule, which serves our purpose from a climate perspective of sequestering or bounding that CO2 into a big molecule. What's left behind is the raw elemental calcium, and that's available for biological use. So it's really a win-win. We take from the limestone what we need from a carbon perspective, all the while supplying this fundamental calcium that is not only needed, but has for 50 or 60 years largely been missing from a lot of our ecosystems because we've stripped it out by pumping stuff into the atmosphere. This is a shell of a freshwater mussel. Found it just on the bank of the river here. A muskrat had accumulated several of them and had a little snack. This is a classic example of a calcifier, an organism that collects calcium from water chemistry and then builds an exoskeleton or a shell. So this shell, when the animal was alive, it was working hard to build this and concentrate that calcium. After its death, what we see here is some pitting around the outside. A lot of that pitting is actually indicative of the acid in the water eroding the CO2. So it's just a really fortunate example of a complete display of how chemistry and humans introducing things like CO2 at an unnatural rate really affect how organisms live in the environment, and that reverberates through the whole system.